Okay, I think we're a little bit late, so let's just start right away. Let me start with a question. How many of you used Terraform before? Okay, quite a few. I'm really glad. So today I would like to go through a few agenda points. First, we will try to define what actually we would like to solve today. Then we will try to respond to a question how, and at the end we'll say why that choice is and not the other. Maybe it's not very straightforward, but yeah, I think it will make more sense that way. First of all, let me introduce myself. My name is Wojciech Krysmann, and I come from Poland. I work as an infrastructure team lead in OLX Group. I started as a sysadmin. I worked like that for a few years. Then I moved to the more cloud-native workloads and worked with OpenStack. Now I work a lot on AWS. Besides that, I'm flying drones and building electronics. And this is my son. Some say that OLX is the biggest company you never heard of. We operate in 33 countries. We have 35 offices, more than 5,000 employees, and actually we're the biggest classifieds websites on the world. Unfortunately, we don't have OLX in Spain, but it can change on some day. But besides OLX, we also run a lot of other businesses within a group, like Letgo. You have Letgo here. We have guys from Letgo. Hi. And some others, but let's move forward. What we would like to cover today. As an OLX group, and we decided that we'll shift our workloads to cloud, as many companies do, so it's nothing innovative actually. But then we will start thinking, guys, we have tens of gigabits of user traffic. We have a lot of developers doing releases a few times a day, and the worst part, we're running a monolith, which is not the best fit for the cloud. This was a few years ago. Afterwards, we, on the other hand, move everything to AWS because that's our provider of choice. Regardless of that, we start reading some manuals, best practices, and so on and so on. And this slide shows what actually is recommended path to grow into collaborative infrastructure as code. We had a lot of discussions around that. Oh, sorry, this is actually recommended by Hashicorp in their documentation. We said no, we'll not go for evolutionary in evolutionary manner because if you build infrastructure manually and then you want to automate, it sounds like more troubles than building it from scratch as something new, something which will work for us. So this is the approach we choose, from manual directly to collaborative infrastructure as code. And as I mentioned at the beginning, we also wanted to leverage the split migration. So first of all, we started building teams which were running services, breaking the monolith. And from the other hand, there was a team. This migration actually finishes as we speak, migrating the monolith into the cloud as well. I will not cover the part of monolith, but focus today on what we've done for the services. So how we decided to proceed? Let's set up we set up for ourselves some rules. There are only 3. First of all, we started greenfield. So we created new AWS accounts, empty accounts. Why 3? Production, staging, and tooling account, which I explain a little more in detail later. But this is what we decided, to not create any problems at the beginning. So the second very important point is no manual changes. We set up that rule, and we had countless discussions how to enforce it, as we knew that we will be granting access to wide variety of people within the organization to that AWS accounts. After some discussions, we decided to not grant right accesses to our developers and infrastructure team. Instead of that, let's run all the changes through the pipelines. This will enforce the full infrastructure as code without any manual intervention. And last, most obvious point, I believe, full automation and infrastructure as code. Okay, on this slide I put few general best practices, which can be easily Googled probably, but they are, I will iterate through them very shortly to add some comments. I will keep reviewing Terraform plan, as it's rather obvious that even with full automation and running pipeline, you don't want to just blindly apply everything you wrote. So we still keep this this workflow that we're accepting changes manually when it's going to production. Many of you may know, but saving plan to file is the best practice to avoid changes in the middle of or in between running Terraform plan and Terraform apply. It's slightly easier in new versions of Terraform when you're doing it manually, but if you're going through the pipeline runs, you can go get yourself a coffee, and then something could change in the repo. Terraform FMT, it's a very nice command which allows you to clean up the brackets and so on in the code, so it's really nice to use it from time to time. Bucket versioning for TF state. Does any one of you had issues with TF state, with broken TF state? Nope, you're lucky guys. It happens from time to time. There are some conditions where TF state can get broken. So it's really cheap and quick and easy method to just enable bucket versioning, which holds the TF state. Oh, and actually I should go in the different order, because first of all you should keep TF state in S3 repo. This is an example implementation. It's really simple. Do not use target. We are really against using targets, and that's why the target works like that you can actually execute only a part of your Terraforms. If you start using it on daily basis, you can end up not be able to run the full apply without a target, so that's why I would recommend to not use target. Do not keep too many resources in one directory. I will skip it, as I will get back to that later. Do not create bucket per TF state. If you have too many buckets, it's getting unmanageable, so we decided to create one bucket per account. TF state can be kept in a directory. This is an example. Don't keep secrets in repo unencrypted. Seems like an obvious thing, but for now Terraform does not give any possibility to work this out. So if you want to be pragmatic, there are projects like Gitcrypt, which could encrypt certain files in a repository. If you have more time, you can go with Vault, for example. Don't try to build abstract general purpose models. This can sound like anti-pattern, but from the other hand, Terraform was designed in a way that it's not an abstraction layer of normal language, but it's really it's the clarifying language. So you have to declare everything, the procedure which should be, or the state of the infrastructure which should be. It should be present on your AWS account, let's say. How to implement all those best practices, all those rules which we set up. This is what we came with. So what's important on that slide? There is a GitHub repo called infrastructure, which will be responsible to keep foundations of your infrastructure. So VPC, network gateways, but also some stuff from other providers like CDN provider or DNS provider. So as an infrastructure team or people responsible for infrastructure, you can keep you can keep track or what subnets you're using. Let's say if you allow service owners to set up their own subnets, you can end up in a situation where they're overlapping. But we get back to that. Then we would like to fetch data and actually allow service owners to build their infrastructure. It can be databases, queues, instances, whatever they need to run their service. In OLX, we work in packs. So there are interdisciplinary teams which are handling some topic, basically. So one of our requirements was to allow those services to operate as quick as they can, to deploy on their own schedule and so on. So we combined these parts of infrastructure with the application repo. But let's start with the infrastructure first. This is how example infrastructure repo could be aligned or create or we have different providers here like AWS, Cloudflare, Ultra DNS, monitoring systems. There are plenty of providers for Terraform which you can use. But let's focus for a moment on AWS, which I bring up earlier. We structure it like that. So name of the provider, environment if applicable. This is one of the pain points of that infrastructure, as we don't want to duplicate code for each environment, but for us it was easier to run like that. It's probably not mandatory step here. EU Central 1, the region of AWS, because some of the services running multi-region. Front end, which is the name of a service, example service. And then we put directories for some basic stuff. We cut even further from the not only building a service consisting of all the Terraforms applicable to it, but cut it even further for some building blocks which we think make sense. And then there's a main TF, which also have a special structure in our case. So here it is. As you can see, it seems to be pretty complicated, and the code is deep inside the repo, but at the end, it will gain you, it will avoid you some headache. Let's move forward to how does the directory in so we actually created a directory in application repo called infrastructure. This is our standard, and that's what this part will be covered by. this is how, yeah, as I said, the directory called infrastructure. Then again, providers. There can be a variety of providers. We like to treat services in OLX or infrastructure of OLX as the whole, not only covering AWS as code, but also incorporating other services. It's not here on the example, but you can imagine that service X could use DNSs, so it could be the possibility of changing DNS zones could be delegated to application repo, which give a lot of flexibility for the team to do, I don't know, A/B testing, for example, green-blue deployment, and so on. Besides of that, rest of the layout is pretty similar. It's provider environment, which is, I would say, not mandatory. Name of region and the TFs. So we don't usually divide it even further for catalogs in application repos, as they want to, as product owners or product teams want to deploy those Terraforms all at once. I mentioned that main TF has some special form in our organization. We decided to keep it as simple as possible. So we only declare a provider here and the S3 backend. And for infrastructure, that's it. There's never something else here. But on the app repo, it's getting a little bit more complicated. There's a provider, TF state of application repo, because it's a different thing than infrastructure repo. Then we have data feeds. So we want to feed data from the infrastructure repo. How does it work? In this example, we have to declare that we want to import the network part from the remote Terraform state, which is somewhere there on such bucket in that directory, which means that we will have access to all the outputs of that TF state. And this is how we can split the infrastructure for those two, how we can split the infrastructure here and feed the data from the infrastructure. So VPC IDs, subnet IDs, security group IDs, whatever we would like to create here on this level and feed it back to certain services. I mentioned outputs. Here they are. So this would be declared in infrastructure repo. We have a VPC ID, which will have value of module VPC and variable VPC ID, and this will be exposed to application in order to make use of it, because you probably would like to know in what VPC you operate. Same goes for subnets, and so on and so forth. And this is how we can use those variables. We have a target group on load balancer for service called Wasabi or whatever. It runs on port 80, and here's how we use variables from remote state. It's called, a provider is called data, Terraform remote state network, which was the name of our service in this particular case, and VPC ID. What would be the workflow for such repo layout? Let's start with infrastructure again. This is a very simple workflow which could apply to many organizations, I believe. With this exception, that as I said, we love to think of our infrastructure as one big piece of website. So basically, we run a website and not the AWS services or DNS services. So if we make changes, we sometimes need to make them infrastructure-wide. So that's why this deploy could actually, on infrastructure level, can deploy multiple services at once, or maybe not at once, depending on the layout. On platform size, it's pretty similar. I've added here a Packer workflow, which we commonly use for EC2s to build immutable images. So after the commit comes to Git repo, it's hooked. It makes a hook to Jenkins, or it's not actually a Jenkins. I just put it in the sake of nice logo, but it can be code deploy, it can be GitLab, it can be anything you like. And we have a Packer here, which will build an AMI. I will go into more detail in a minute, and then feeds the AMI ID to Terraform, which again will deploy various services. We also include monitoring. We declare it as code and deploy it together with the rest of infrastructure, because it's easy to imagine that you change names of our load balancer, let's say, so we want to accordingly change the monitoring. This is how could a simple builder in Packer look like to build an EC2 with your service. So we also declare EC2s as code and run immutable when applicable, and for most cases it is. Here we are, to not go into too many details, here we're running some basic stuff with a bash script, and then Ansible kicks in and build a service. In this case, it will be, it's actually a production example. It will be a resize service which we run. How the deploy would look like? We're passing a variable to Terraform with image which was built by Packer, and deploying it as usual. There's nothing fancy on that slide. Why we make so choices? Why we want to split infrastructure part from application part? First of all, there's a nice trick which we're using, which I will get into on next slide, but do you recognize such questions? Do you ever had such questions on your organization? I see some people shaking heads, so I can imagine that, yeah. So here's a very nice trick to solve that issue. Many people don't know that in Terraform you can output actually values, not necessarily output of something, or not necessarily output of executed stuff, but basically values. By the way, those are randomized, so you will not hack us. So we have in infrastructure repo, we maintain the list of our office IPs. In this case, it will be Mercury, because on previous slide, this is an Apollo 11 control center. So Mercury project, office, or whatever you call it, will be outputted from infrastructure and hooking data from infrastructure. So again, we're feeding data from Terraform remote state called whitelist, and we bring that exact output here, and that's it. We are good to go. Whenever this one will change, in your next Terraform apply, you will be notified about that fact. And here's another example of the same behavior, Apollo 11 this time. It can be also used as a variable inside. Of course, this is infrastructure repo, this is application repo. Again, you can use Apollo 11 public IPs to whitelist it on your application if needed. Who can find the conflict here? Yeah, there is a conflict. So maybe you had such questions in your organization. We had. That's why keeping the subnetting in infrastructure repo give you a lot of control over that. Usually someone from infra team will will assign the IP subnet which new project can use, apply it, create VPC for them with subnets, with security groups, with all the foundations they need to be homogeneous, but from the other hand, do not step on each other back. We can connect them to VPN and so on. So we wanted to persist granularity, but also gain some centralization. That's the reasons I am on that stage are probably obvious, but I have another question. Do you know what it is? This is not my art or something. This is output of a Terraform plan, which we performed after first attempt of putting all our domains in a single directory. So centralization is nice, but granularity is also needed. Yeah. Fighting for resources. This is a very common problem when your team is growing and when you're performing Terraform apply, doesn't matter manually or through the pipeline multiple times a day, your infrastructure is growing. This is very common, that you're fighting for resources. One apply takes up to 20, 30 minutes, and other guys in the meantime finish their feature and would like to apply it as well. With our approach, we don't have that issue. So I mentioned it a few times already, but we don't treat our infrastructure as those shrimps. We like to think that they are also onions, garlic, and everything else. So CDN, DNS, monitoring, and the infrastructure itself, we like to treat it as one dish, basically. And this is what we would like, what we're trying to achieve with that approach. I can tell that it's working really fine for us. I hope you will find it helpful. If you have any questions, I'm happy to respond. We have 3 minutes. Okay, that's because I don't have a bag with gadgets, sorry. Maybe next time. Thank you very much.